Hi everyone. If you could join the Google Plus, at least the group chat, I'd like to make this as interactive as possible. So, if you could join the Google Plus Hangout, that'd be awesome, and share your video and voice. That'd be great. If not, the group chat, Google Plus group chat would be great as well. We'll go ahead and get started here in about 3 to 5 minutes. Once the viewer numbers start dropping off. Hey, so Nick said that the broadcast page, the YouTube broadcast page, was working, which is great. Thank you, Nick. We were unsure whether people on YouTube could actually see this video or not, so that's good that they can. There's a QA question answer portion of this app. So if you want to ask a question, like you don't want to necessarily interrupt, but you want to put the question in there that I can answer later, that'd be great. The same thing with the chat. There's a chat window as well. Please feel free to type into the chat window. Stop me at any point something doesn't make sense or you have a question, and I'd be happy to kind of break and answer it there. Like I said before, I'd really like this to be as interactive as possible, and the presentation's like really short. So if we don't have any questions or people don't chime in, we'll just end up finishing off early. Can somebody go ahead and type something into the group chat just to make sure that I can see it working? I know the QA part of this is working. Just want to make sure the group chat's working. Not seeing anything coming up in the group chat, so we're going to have to probably rely on the QA to ask questions and answer them. Okay, let's go ahead and get started. It's 5 minutes past the hour. We've got 11 people on here. Thanks for joining. This is the first Google Hangout I've ever done, so apologies if I mess something up. My name's Manu Sporny. I work on standards through the World Wide Web Consortium. So for those of you that don't know who the W3C is, they build standards for the web. They're the organization that effectively built the web. They're a membership organization, so basically what that means is that there are 400 companies that include companies like Google and Microsoft, and Facebook, Hewlett-Packard, and every big technology company that you can think of is a W3C member, or most of the large ones you can think of. And together what they do is they pool all their technology resources together to work on standards like HTML5 and CSS3 and standards like that, things that you use to build websites and web pages. And so the standards that are created there are used by all the browser manufacturers and effectively the 3 billion people on the planet that use the web. Right, so it's a fairly big deal to get a standard through the process because it has to scale to that level. You need to make sure that the technology that you're creating is actually usable not only in the US but Brazil and China and Japan and Europe. I mean, all these places basically end up using the same standard. And the really cool thing about the W3C is, unlike a lot of other standards bodies, their standards are always released in a patent and royalty-free manner, which means that there are no gatekeepers keeping you from putting something up on the web. If you can get a web server up onto the internet, you can serve web pages, and anyone in the world can view those documents that you're creating. So that's a pretty big deal. We weren't able to really do that before the web came along. So numbers: 400 member companies, probably around 1,900 engineers. I have my own company called Digital Bazaar that works on technology that we try to put through the standardization process at W3C. Okay, so that's basically it for W3C. W3C builds the framework that the web runs on. Without the W3C, there would be no web as we know it today. And the specific thing that I'm talking about today is a new standard called JSON-LD, which stands for JavaScript Object Notation, JSON, for linking data or linked data. So I'll go into a bit about what linked data is about, why it's important, and then go into a high level of what makes JSON-LD slightly different from JSON. So at this point, are there any questions? Anyone want to put anything into the QA? Let's see. So there's a question on how do we join the group chat. Unfortunately, so this is my first time using Hangouts. I have no idea. I went to Google Plus, and there was a little start button by the event. So if you go to the Tulsa Web Devs, website, there should be a link there for the Google Plus Hangout, and there should be another link for the YouTube link. So if you're on YouTube watching this, you're in the wrong place to do the group chat. So go to tulsawebdevs.org, I think, or search for Tulsa Web Devs, and there's a February meeting link there. Click on the February meeting, go down to JSON-LD, the JSON-LD talk. There'll be 3 links. I think you want the second one, the one to the Google Plus Hangout. So hopefully, Josh, I answered your question. Hopefully we'll be able to get more people in to the chat. The other thing that I can do is I can look at the YouTube stream, and hopefully I can pick up questions on there, but that's always like way delayed from the actual video itself. So let me try and pull that up to make sure I'm tracking that as well. All right, I'm pulling that up now, and hopefully I will be able to see any comments on there. But please join the group chat if you can, because that's going to be the best way to ask questions. Any other questions from folks before we get started? Not seeing anything. Okay. All right. Let's see. Where should we start? So let me start off by talking a bit about linked data and what's been going on there at the W3C. So the W3C kind of came into formation around 1994 to work on some of the core features of the web. So things like HTTP and HTML. Those were being worked on both at the Internet Engineering Task Force and the W3C. W3C kind of took over the front-end stuff, HTML and CSS, while the protocol stuff went kind of to the IETF. Oh, unfortunately, someone's saying that it's invite only for group chat, which is unfortunate. Let me see if I can invite. If I can invite people. So I'm going to do a public invite, which basically means anyone can join. It's not letting me do it, unfortunately. So how about this? Maybe I can add Josh. No, it's not even letting me add Josh, I don't think. Yeah. Sorry, folks. This is, again, my first time using this stuff, and it's fairly difficult. Yeah, so Josh, I can like add you to my circles, but I can't see where I can like invite you just directly. If anyone knows how I can invite folks, please put it in the Q&A bit or whatever, or how to just open the call up to everybody. It looks like I have to like manually invite people, and to do that, I need to know your Google Plus account's name and be your Google Plus buddy. Okay, so back to the W3C. So W3C started around 93, 94, worked on CSS, HTML, and around like 2000, Tim Berners-Lee Tim Berners-Lee was the person that created the web effectively. Him and one other person ended up coming up with the core idea, the core framework around the web. And Tim Berners-Lee felt that the web should be something more than just a document storage and retrieval mechanism. Tim felt that we wanted to be able to publish documents on the web, but what we really wanted was a data web. We wanted to be able to publish our data in a machine-readable way on the web, and by doing that, we would be able to query all of human knowledge much more readily, right? So what actually ended up happening is we ended up creating, we went off, like all the web developers, engineers ended up going off for like 10 years, and we ended up creating this document-based web. And that really wasn't the end goal of the web. The end goal of the web was basically, or the end goal as far as Tim saw it, was to create a read-write web, web that you can both read and write. And today, the only write that we can really do are to the web servers that we have control over. The original vision was to be able to read-write any website. We should be able to go to any website, highlight a piece of text, modify it, and hit apply, and that change. So we've seen bits and pieces of that in like wikis, but we haven't seen it to the degree that that was there in the original vision, right? So linked data is effectively about changing the web not just into a read-only, bunch of human-readable documents. Linked data is about changing the web into a gigantic data store, the largest database that has ever been known in history, and to do that in a way that machines can then reason over the data. Right? So they know that when they go to a particular piece of data, they know if it's a person, place, or thing. They know that person's relationship to everything else. And to do that in a standardized way, a way that scales to the 3 billion people that use the web today. Okay, so let's see, Brad is saying that in the upper right corner is an option for QA. I am not seeing it. I don't see how to just allow everybody to join in, which I would absolutely love to do at this point, but the interface is fighting me. Yeah, Brad, could you be more specific on the option for QA for me to be able to like invite people in? Because that would be awesome. I would much rather have a conversation rather than sit here and talk about JSON-LD for an hour. Okay, so going back to the original vision for the web, we wanted basically this gigantic database that machines could look at and reason over. So the question is, so in 2000, W3C kind of started launching this thing called the Resource Description Framework. It's called RDF. And the idea behind RDF was to be able to publish data in a way that machines could consume and reason over that data. A lot of people called it the Semantic Web. And let's see, the views can select from their screen. Oh, okay, so Brad was giving the information for other people. Viewers can select from their screen to join, hopefully, maybe, I don't know. On the top left there should be a little chat icon. Hopefully you can click it and start chatting in there. Okay, so linked data, the whole idea here was to try and make the web a machine readable database where you could reason over the data, where a machine could reason over the data. So a machine would be able to know people, places, and things, and how they are related to one another. You could ask it questions like, who was the president of the United States in 1957, and who were all their siblings? Show it to me in a list, right? Or give me phone numbers to any living relative of that president's relatives 50 plus years ago, right? You can't really ask the web questions like that today. I mean, Google kind of has that in the Google Knowledge Graph, which is using linked data and semantic reasoning. But the idea, again, the idea here is, how do we start marking up information such that machines can actually understand it? So to join the QA, you can click on the square and choose QA on the left hand of the Hangout. So if you're looking at the Hangout, it's on the left column. It says QA. Thanks, Bill. And then, let's see, to join QA, Brad is saying, to join QA, viewers can choose QA from the menu in the upper right of the video and choose QA. And the menu, I think, differs depending on the version of Google Hangouts you're using, but that's one way you can join. So RDF, W3C created this RDF thing. And they created this format called RDF XML, which was pretty awful. It was actually a really horrific format to use. It was very difficult to understand what was going on. It mixed all the worst parts of semantic reasoning with XML. It was a train wreck, effectively. And that's not to say that the people that were working on it weren't really good, smart people. It's just that it was this thing that had never really been done before. No one had attempted to create, a worldwide database for machine reasoning. And so some of the core concepts stuck around. A lot of developers kind of wrote it off as this, pipe dream, this idea that we'd have machines crawling across the web, working on our behalf to do things like bias healthcare and figure out the best movie that we'd like and things of that nature, right? So that was around 2000, early 2000. So let's fast forward to like 2006. RDF started to be seen again with its thing called RDFA, the Resource Description Framework and Attributes. It allowed you to put kind of machine-readable hints into web pages. And I was the chair of the RDFA 1.1 group at W3C that created that standard. And while we were creating it, the biggest problem that we hit, and this is when Google adopted it. So Google adopted RDFA and microdata. If you know what microformats is, that's also in the kind of the same vein. And the thing that ended up happening, or the thing that was problematic, was that people really didn't understand the best way to use RDFA. Like with RDFA, you could give hints to the machine. So you could say like, this paragraph of HTML contains a person whose name is this, whose phone number is this, and whose home page is at this location, right? Before, the Google search engine would have to scan the page and kind of guess as to where that information was. It was a whole bunch of like heuristics and machine learning and natural language processing that had to happen to get that right. And it's not very accurate. At least back in 2006, it wasn't very accurate at all. And so Google was kind of looking for a way to help web developers mark up the things that were important to, for example, Google and the web developers. So Google said, look, you could use RDFA to mark up pieces of your web page so you can point out people, places, things, and events. And if you do that, in speaking to Google, speaking to web developers, if you do that, you'll get a really nice, rich search snippet result when somebody searches for something that matches what you just talked about, right? So if you talk about a person or an event that somebody searches for in Google, they'll see this really nice display on when the event's happening and how to join the event, and open up the location of the event in Google Maps. So RDFA effectively helped web developers mark things up in a fairly easy way on a web page, and then it allowed developers mark that information up, and then Google would come along, scrape the data off the page, and know exactly which event or person or place or thing that you're talking about. There's no more heavy-duty AI that's needed to do that. It's effectively read the tags off of the web page to find out what's going on. And so the problem with RDFA, though, was that it was brittle. You'd put it in a web page, and a web developer would go through, or a web developer that knew about RDFA would go through and mark it up in the page. And unfortunately, a designer or a JavaScript developer or someone that didn't quite know what that markup was would come along and rearrange the content in the page and completely destroy the machine readable data. What's worse is that they would move it around in such a way that the machine readable data was completely wrong. It was worse than the natural language processing that Google was taking. It was just flat out wrong. Right, the structure of the page was changed, and therefore the machine-readable information was changed, and just bad things happen from then on out. You start getting miscategorized in Google. So we took a step back and we said, look, maybe there's a way to use JSON to express this information on a website, and wouldn't it be nice if we could make the JSON data not just machine-readable in that machine could pick it up and then a programmer could figure out which fields they wanted to use, but wouldn't it be neat if we could express information on the web using JSON in a way that gets us to this kind of linked data future, this idea that you could have machines look at a web page and understand people, places, events, hospitals, things like that. They could just extract it from the page. So that's kind of where JSON-LD got its start. It was an attempt to try and achieve this vision of linked data in the semantic web. So at this point, are there any questions? That's just a real quick, brief history lesson of the dawn of the web to where we are today. Any questions about any of the historical stuff, where JSON-LD kind of came from, where RDF or RDFA came from? Okay, while people are typing, I think that the best way to really look at JSON-LD is to just look at an example, right? Look at what we had with JSON and then figure out what JSON-LD actually buys us. So let me go ahead and try and share my screen here. Okay, so let me switch over to JSON-LD. So what I'm going to do is show you an example in the JSON-LD playground. So there's a website called JSON-LD.org, and if you go to JSON-LD.org/playground, that lets you kind of play around with JSON-LD. And what I'm going to show you here is basically the type of JSON data that we deal with today. Right, so Yeah, JSON for hopefully everyone in the call knows what JSON is, but if you don't, a real quick highlight. JSON is basically the data format that a lot of websites use to move data from from basically the server to the client and back to the server, from the client to the server. So you've got to express the data that you're sending in some kind of message. And JSON's really nice because JSON has these nice key value pairs that outline the data that you're sending. So yeah, I mean it's fairly human readable, right? I mean, you know that they're key value pairs, so the name of this object or the name of this thing that's being described is Jane Doe, and their job title is that of a professor, and they have a telephone number, which is this value here, and then they have a URL or a home page that's this value, right? So fairly simple key value pairs, and JSON has really excelled at making it easy for web developers to mark up this type of information when they transmit data back and forth between server and client. Now the problem here is that when one developer uses name or they use URL, that might be slightly different from what another developer uses. So for example, another developer might use tel for the telephone number, right? And then even though the same kind of information is in there, the machine that's reading this has no idea if this telephone number is actually expressing the same kind of data as this telephone number, right? So let's say this is 321. We have no idea. So the developer knows. Because they're the ones that are writing the program and expressing the data. But the problem is that the machine has no idea if this piece of data up here, telephone, and this piece of data down here, tel, are actually expressing the same type of information. You know, is it really a telephone number, or is it just a Boolean value, yes or no, piece of text that says whether or not they have a telephone number or not? Right, and so this is the problem, right? When a machine looks at this, it has no idea what any of the data actually means, right? It has no idea to figure out if the way this developer is using name on this site is the same as another developer using name on another site, right? So there's no way to know this. So this is a problem that JSON-LD tries to solve. And it tries to do this through something called a context. Right? So JSON-LD, by the way, a JSON-LD is completely compatible with JSON. JSON-LD is just JSON with a few other key value pairs added. Right? So it's not this completely new language that came out of thin air. JSON-LD is JSON. It's just you add a couple of new keys, key value pairs to the JSON to make your content machine readable. So let's take a look at what a simple JSON-LD document looks like. So this is it, right? So the difference between a JSON document. So this is a JSON document right here, name Jane Doe, yada yada yada. The difference between that and a JSON-LD document is one line, right? This context. So this context line here is JSON-LD. That is effectively adding what's called a context to your JSON data. And a context works very much like a context when you're having a conversation with someone. Whenever you have a conversation with someone, it always happens within a context. So when you use words like he or she or it or they, the person that's listening to you speak knows who you're talking about. They know the specifics. There's a context that's wrapped around the conversation. So when you say he, the person that's listening to you knows, oh, they're talking about Jane Doe, right? Or they're talking about John Doe or Bob or whatever. So when you use the word he, you're using a context that exists between the sender of the message and the receiver of the message to make it clear, more clear, specific about exactly who you're talking about. So a JSON-LD context does exactly that to the data. So for example, this context, and context very much is linked with vocabulary. So this context outlines exactly what we mean by name, and exactly what we mean by job title, and exactly what we mean by telephone, and exactly what we mean by URL, right? So that there is no confusion over what we mean by these key value pairs, right? So what I'm going to do is I'm going to add one more piece of information to this JSON-LD document, and that's the type of object that we're talking about. So again, we have the context, the JSON-LD context, which uses the schema.org vocabulary. And the vocabulary defines what name and job title and telephone and URL mean. Right? And when I say mean, I mean mean in a specific way, a machine understandable way. So the type of object that we're talking about is a person, the schema.org person. And the person's name is Jane Doe, and the person's job title is professor, and the person's telephone number is this number. And if we actually look at schema.org, so I'm going to jump over to person here. So this is, if you look up at the URL bar, it's schema.org/person. So this thing, this vocabulary term that we've called person, has a definition. So it's a person, alive, dead, undead, or fictional. So, you know, undead covers zombies, so that's good. So this type here, this person type, can have a whole bunch of different properties associated with it, such as a birth date or a birthplace. You can specify the children that the person has, their height, job title, who they know, their nationality, their net worth, who their siblings and spouses are, their tax ID, weight, who they work for. You can show an image of that person. So all of these are properties that you can express, machine-readable properties that you can express in a JSON-LD document. So I think that the question that some people might have at this point is, well, how do you know? You know, how does the machine know that what we mean by name? Like, how does it not get confused with some other context, right? And the way that it does this is it maps. The way JSON-LD does this is this context will actually expand name out into a URL. So when the machine reads it, what the machine's going to see is this: http://schema.org/name, right? So if somebody else comes up with their own name, they're gonna scope it to their own website probably. So let's say example.com, myvocab/name, right? So so this is when the machine actually goes through and reads this, the machine is going to know that this name, schema.org name, is different from this name, which is myvocab name, right? So that's how we kind of give global context to a lot of these key value pairs. And if we look back at you know, the JSON before, let's see. So if we look back at just the pure JSON before, you'll notice that there's no context around what we mean by name here, right? The only context is something that's out of band. There's nothing in band telling the computer, no, this type of name versus this other type of name. Okay, so I'm gonna stop there and quick look at the QA thing. Okay, and there are a couple of questions up here, so let me go to them really quickly. Stop screen sharing. Okay, so yes, undead or fictional. So if you look at the schema.org person class, it talks about, you know, undead or fictional or all those types of things. All of these concepts are really important for machines to know. A machine should know that Sherlock Holmes is a fictional character, right? It should know that, oh, now I can't think of a good undead character. But it should know that certain characters are undead versus real people, right? Because that it matters when you're reasoning over things, right? If you ask a computer, give me a list of all the living people that you know of today, it can it can filter out Sherlock Holmes and any undead characters that are in books. Frankenstein. So I don't know if Frankenstein is technically undead. Anyway, so it's these types of distinctions that are really important for a machine, because it's the difference between having AI that's just kind of funny to use, right? It gives you the wrong answer 20 or 30% of the time, or AI that's seems like it's incredibly intelligent, like, for example, the Watson supercomputer. So all this data is important, right? By itself, each data point isn't really important, but the more data points you add, the more Watson-like supercomputer you get. Okay, so that's the undead or fictional comment. When did the JSON-LD standardization process begin? About 3 people, myself, my company CTO, and a guy by the name of Mark Burbeck, started creating JSON-LD. When was that? Probably around 3.5 years ago, probably around 4 years ago. And it was really just 3 of us working on it for a good long while, for about 1.5 years, 2 years, until it became fairly apparent that we were onto something. Other organizations were saying that they thought it was interesting, and then at that point we put it on the standardization track at W3C. And there's a whole process that you have to go through to do that. But the basic idea is you go around to the W3C membership and you say, does this look interesting to you, right? And then there are a bunch of competing standards that kind of go into the the standardization fighting pit, for lack of a better way of putting it. And then typically only one standard emerges. Sometimes 2 emerge, and that's usually a result of a failure to standardize. But the idea here is that JSON-LD was kind of a success story, right? So JSON-LD was created in what's called a W3C community group, which is basically anyone can create one of those groups. If you have a really great idea, you can create a W3C community group and pursue your idea there. You pull in companies, get people to comment on it, write a specification, and then do implementations. And if enough people take notice of it, you can put it onto the official standardization track at W3C. So JSON-LD spent around 2.5 years out of the standardization body. It just us working on it and hacking on code and seeing if the ideas that we had would actually work at the web scale. Once we figured out that it should work at the scale of the web, we had a standardization group called the RDF working group. So this was the Resource Description Framework working group. We had the RDF working group ask us to bring the work inside W3C. And in fact, we fought it. We didn't want to put it in W3C because we felt that it wasn't a very friendly place to do this kind of work. But we were very lucky in that the chairman of the RDF working group really saw the vision of what we were trying to do with JSON-LD, and really put it into the group. And it was probably no more than about a year to 1.5 years later that we had a fully ratified web standard. It moved very, very quickly. Typically, W3C standards take between 4 to 6 years to complete. And that 4 to 6 years is, it takes so long to complete not because the technical work is difficult. I mean, the technical work itself is incredibly difficult, but the part of it that's more difficult is getting everyone to create consensus around the standard. So W3C is a consensus body, which means that you have 400 organizations that have a say on whether or not the standard goes through. And if any of them object, you have to talk about the problem, come up with the best technical solution for it, and kind of get it through the process like that. So the thing that takes the longest amount of time in setting these global standards for the web is not the technical side. The technical problems are usually solved in about 20% of the time. The other 80% of the time is taken up convincing large organizations like Google and Microsoft that this is something that they don't want to, that they want to support, or at the very least, not try and block. So, yeah, the JSON-LD standardization process probably started. The technology was created 4 years ago. The standardization process started around 2 years ago and was done in about 1.5 years, which was actually really, really fast compared to something like HTML5, which took over a decade in lots of really nasty fights between XHTML2 and HTML5. Okay, so hopefully, Nick, that answered your question. Ed Cho is asking, is the taxonomy extensible? Yeah, so it is. And the really cool thing about RDF, the Resource Description Framework, and JSON-LD, and anything built on top of the RDF data model, is that you don't have to be Google to create your own taxonomy. If you have a really great idea, you can create your own taxonomy, publish it on your website, and other people can start using it. So if you wanted to extend that person object, that schema.org, and schema.org is really Google, Yahoo, Microsoft, and Yandex, right? And they created that schema.org taxonomy / vocabulary because they wanted to give web developers an easier way of marking up the things that are important to the search engines, right? Now, there are complete other market verticals that don't really care about search at all. They care about, for example, medicine, drug discovery, the ability to examine biological processes, physics, space. Each one of these can have a completely separate taxonomy, completely separate vocabulary. And the really wonderful thing about RDF and JSON-LD is that you can pull taxonomies in from different places. So you can pull something in from schema.org. You can use the schema.org vocabulary. You can use a space vocabulary. You can use a biology vocabulary. You can use a vocabulary that you created, and you can mix them all together, and all the data doesn't get into this jumbled mess, right? It's not like JSON, where you can't just copy and paste like a Twitter JSON message with a Facebook JSON message and expect the resulting combined information to be understandable after it's been combined. Whereas with JSON-LD and RDF, you can combine data from a bunch of different sources, a bunch of different vocabularies, and it all just works, right? It's designed for that. So yes, the taxonomy is extensible, but you don't have to worry about convincing a large organization to extend their vocabulary. If you have a great idea, you just create your own taxonomy, put it up on the web, and other people can start using it. And I'll show you exactly how that happens here in a little bit. Thanks, Ed Cho, for the question. Matthew is asking, who is using JSON-LD on the web right now? Google uses it, Microsoft uses it, Yahoo uses it, Yandex uses it. If you use an Android phone, JSON-LD is on that. For example, if you have Google Now is powered by JSON-LD. Actions, email actions. So many of the major email providers have these things called actions, schema.org actions. So if you get something in your inbox that has this thing like pay with Google Wallet, or pay with Microsoft's wallet solution or Yandex wallet solution, all of that uses JSON-LD. JSON-LD has also been installed in things like dishwashers, so Internet of Things needs a way to send messages in a fairly extensible manner, and so the messaging format is JSON-LD for a lot of those Internet of Things devices. JSON-LD was actually, the reason we created JSON-LD was not for search at all. We, in fact, had no, Google was not even on our radar when we created JSON-LD. We were focused on trying to create a way to mark up products and items for sale on the web as a part of this initiative, broader initiative called the Web Payments Initiative on the web. So W3C currently has an official activity around web payments. What we're trying to do is standardize the way we both send and receive money on the web, whether it's through credit cards or Bitcoin or Ripple or Ethereum or cryptocurrencies or fiat currencies or ACH, direct debit. It shouldn't matter. It should just be one simple process on the web, meaning you go to a website. You don't have to sign up for the website. You just click the buy button. It says, this is how much the merchant would like to be paid. You click yes, and you're done. Payment sent, right? I mean, we're trying to do for payments on the web what email did for communication on the web. And so in order to make that happen, we need a really nice extensible data format like JSON-LD, where you can mark up things like people, places, things, products, items for sale, digital receipts, all that kind of stuff. So a lot of folks are using JSON-LD on the web today. Most people are using it for SEO, but JSON-LD is being driven into a lot of the core technology that W3C is creating for the next generation web. So you're probably going to see a lot more of it in the future. So hopefully, Matthew, I answered your question. If I didn't, please let me know. So Brad is saying this is not historical, but we just marked up our AngularJS single-page app with events, attractions, etc. using schema.org JSON-LD. We implemented schema.org JSON-LD inline versus in the head. What is the best practice? It's early, so there is no best practice. You can put it in the head, you can put it in the body. Google or Microsoft or Yahoo or Yandex or any other organization really will pull it out in the right way. I mean, you said you're using AngularJS. A lot of these search engines now actually run a JavaScript engine in there. So they will run the JavaScript on your page and extract any JSON-LD in a script tag from that page. So if you remember back, I said RDFA was used to express information in a web page, and that was using like HTML. It was adding attributes to HTML to do it. There's an alternative now, which is just putting a JSON-LD chunk into your web page, and that will give a hint to the search engine companies or any application really that's looking at your web page. It'll give it machine readable hints about the things in your page. Okay, all great questions. Okay, so let me jump back into screen sharing and kind of show you what JSON-LD data and RDF really look like what the machine sees versus what the human sees. So let me go ahead and share my screen once again. JSON-LD Playground. Okay, so if we look back, so this is a JSON-LD object, right? It's got a context, and that context tells the machine how to interpret name, job title, telephone, and URL, and things like that. And so what I'm going to show you right now is what the machine sees. So the web developers see this, and this is not too different from the regular JSON web developers work with. But a machine needs to know specifically what name means and specifically what job title is. So let me go down here and look at let's see, expand now. Let's look at the NQuads. So don't worry about what NQuads is. It's just another RDF syntax. But it's a way of showing you what the machine's actually seeing here, right? Let me actually give this person an identifier. And I'm going to give it an ID on the web, right? Example.com people Jane. Okay, so I'm now given that object an identifier, and if I look down at this data, this is what the machine sees. These are called triples, right? So a triple is basically a statement, a machine-readable statement, and it has a subject, like who or what are we talking about. And so since we gave Jane this ID, that's a URL, that uniquely identifies Jane. It's, URLs are a global identity mechanism, a global ID mechanism. So once we give Jane a URL, we can refer to Jane and make statements about Jane. The next thing that we'll see here is a property, right? This is called the technical term for it is a predicate, but it's basically a property. Like it's something about Jane. How tall is Jane? What color are Jane's eyes? What's Jane's job title? What's Jane's name? Her telephone number, all that kind of stuff. So while the first field here in a triple is the subject, the second field here is a property about that subject. So Jane's job title, and then the third item here in the triple is called the object, right? What are we talking about? What's the value of the data? So the way that you read a triple is is subject, property, object, right? So Jane's job title is professor, and then the period at the end is the end of a sentence. So it's like a really simple English sentence, right? Subject, property, object. Most English sentences can be expressed like that. So that's one fact about this. It's one fact about this thing that we're talking about on the web, right? The second line here is another fact about that thing. So Jane's name, Jane's schema.org name is Jane Doe, right? Third statement, Jane's telephone number is this telephone number right here, right? Fourth statement, Jane's URL is this URL right here. So their home page is this value, right? And so this data is very specific. If a machine were to look at it, it would know without a doubt what we're talking about, exactly which name property, telephone property that we're talking about. Now, if you'll notice, there's one last statement here. It takes up more than one line, but we're saying Jane's, and then there's this crazy URL here, right? W3.org, 1999, 222, RDF syntax, NS for namespace, type. This basically means type, right? The class of thing this thing is. So Jane's type is a person. Jane is a person. So that this statement here basically says that Jane is a person. Jane is a human being, right? We don't know if Jane is fictional or undead or whatever yet, but we know that she's a person. She's not a vehicle. She's not an event. She's not a tree. She's a person. So this is an example of mixing taxonomies, mixing vocabularies from different sources. So this statement is made, this very last statement here, the type statement, is made using a vocabulary that the W3C published in 1999. Right? This is how long W3C has been thinking about this problem. But this vocabulary is very different from the schema.org vocabulary. So schema.org is something that Google, Microsoft, Yahoo, and Yandex ended up creating. But you can mix the data together here, and it's just the machine can just read it. It can read each one of these triples and refine what its view of the world is. Okay, so hopefully that helps you understand how this information up here, this JSON up here, is actually translated into some kind of machine-readable information, right? And I'm going to do a quick search right now in Google. Who is the president of the United States? Right? Question mark. So hopefully, did they get rid of info boxes? Yeah, it looks like they got rid of, or at least my version is not showing up info boxes. Typically, there'd be, if you do this search through another machine. I did this search earlier today. But there's an info box that usually pops up that tells you who the president of the United States is and that kind of stuff. Let's see, is there any? Yeah, no, unfortunately, it's not doing that. So typically, the way that Google answers questions like that is Google has its own thing called a knowledge graph, right? And the Google knowledge graph is just a whole bunch of information like this, statements like this, like Jane's job title is professor, Jane's name is Jane Doe, Jane's telephone number is so and so, and once you get enough statements like this, you can have machines answer questions like if I said, you know, what's Jane Doe's phone number? The machine would know that this property is what expresses a phone number, and it would be able to respond back with, you know, 425, 123, 4567. That's Jane's phone number, and it would be able to say that very plainly, meaning that it wouldn't have to do any machine reasoning to do that. It would just be in a database somewhere. Okay, so I'm going to stop here quickly and see if anybody has any questions so far. Not seeing any questions. And hopefully I haven't lost anyone yet. Okay, so go ahead and put in any questions you have about, you know, JSON-LD or the machine reasoning aspects of it, and I'll try and answer them. Okay, so I'm gonna go back to screen sharing and keep going, but please, you know, add your questions in if you have any. Okay, so this is basically, you know, this is how we get from the web that we're in today, which is the document-based web, to a more machine-readable web, right? So all the APIs that we're creating today, if they're publishing JSON data, right, it's really hard to for a machine to read data from one source like Facebook or Twitter and read information from another source like Google Plus or some other place, and then combine the information together, right? It's all tightly namespaced, meaning that, you know, a Twitter message only really makes sense on Twitter, and a Facebook message only really makes sense on Facebook. But what would happen if Twitter and Facebook started sharing a common vocabulary between each other, right? A social messaging vocabulary between each other. All of a sudden, it would mean that you could write software that would be able to read social messages not only from Twitter, but Google Plus and Facebook and app.net and any social messaging network. They would be using the same kind of data across all those networks. And this is the exact problem that the search companies had, right? All the search companies couldn't go to web developers and say, hey, web developer, if you use the, you know, markup that's really specific to Google or really specific to Facebook, we'll give you rich search listings, right? So when people find your page, they'll see something really special pop up in the Google search results. So as a single organization, you can't make that proposition to a web developer. But if, you know, what the search companies did was they got together and they said, hey, web developers, if you mark up people like this, right? If you mark up a person like this on your web page and you publish it, we will be able to, one, classify you better, put you in a better category, and two, we'll be able to give people that search for your products or services or people or events, we'll be able to give them a really rich interface into your website. And that was compelling enough to a lot of web developers that they started doing that. So that, I mean, that's basically that's the idea behind this linked data stuff. It's let's stop doing all this stuff in a proprietary way, right? The last thing the world needs is another social network that has its own data format, its own way of marking up what a message is, when the vast majority of social networking sites do the same kind of thing, right? When you send a message, there's the message contents, there's the person that sent it, there's the time that they sent it, and a bunch of other information that's common to all social networks. So the question is, are web developers going to actually start creating applications like this? Are they going to start sharing vocabularies? And the benefit to sharing vocabularies, the benefit for web developers sharing vocabularies in the applications that they're building, is that the software ecosystem that we can build around that is much larger. Meaning that if we make it so that the software that's reading one social networking stream can now read all the social networking streams, that means that there's a lot more interoperability between all the social networking sites now. And that's just an example of one industry where this stuff could be applied. Other industries include things like biomedicine or the medical industry. A lot of medicine and medical information is expressed using proprietary, one company only schemes, and that's hindering a lot of medical research because all these databases need to be translated from one format to another format to another format. And JSON, and then a lot of these organizations are starting to use JSON-LD, and they're sharing JSON-LD and RDF, and they're sharing their vocabularies so that there isn't that just base proprietary layer to the data that they're using. Okay, so let me go back and check out the Google Hangout. So Brad's got a question here. So if the information is in the head or inline, does it not also suffer from the problem that web developers and designers can mangle the facts like they did with RDF? So yeah, great question. Let's see. I'm trying to think of the best way to explain how that works. It's still possible that if you put your JSON-LD information in an HTML web page, that someone's accidentally going to fat finger some of the information, or they're going to cut a chunk of it out accidentally, or something like that. The benefit with JSON-LD is that at least it's in a block, right? I mean, at least it's in a block in the web page so that it looks different from everything else around it. The problem with RDFA, the Resource Description Framework and Attributes, the problem with RDFA was that it sprinkled a whole bunch of attributes throughout your web page. So let me see if I can actually bring up. I'm on a closed network right now, so let me see if I can bring up this website, rdfa.info. No, unfortunately not. The problem with RDFA is that it used HTML attributes like property or about that would be integrated in the HTML, so that when a developer came by, or a web designer or web developer came by, they might accidentally change the structure of the page, which changed the structure of the information. So it's much easier to corrupt RDFA data than it is JSON-LD data. The other really interesting thing that happened with JSON-LD was that JSON-LD, we never thought Google and the search engines were going to adopt it and tell people to put it in their web pages, because it violated the whole hidden data rule that a lot of search companies use. They basically said, if you have hidden data on the page, we're not going to index it. Right? Because you could be lying. Like search engine spammers would do a lot of that hidden metadata to try and boost their search rankings. So the way that Microsoft and Google and Yahoo fought back against that was that they said anything that is not visible on the page is not indexed. And so we thought, no way would they actually embed JSON-LD in the page, but they came out and said, you know what, we are approving JSON-LD because it's actually giving our search engine a lot of really good information, and we want to promote that kind of activity. So yes, information in the head or inline could be mangled. JSON-LD data in the head or inline could be mangled, but it's less likely to be mangled than RDF is. And because the search engine companies have now blessed this very specific type of hidden content, as long as it kind of matches what your site is about. Like Google has a ton of other pieces of information about what your site's about. As long as the metadata in there matches what your site's about, it'll get into the search index. Also, so remember, like JSON-LD is really designed to be something that you use with REST APIs. Something like the Twitter API or the Facebook API or a payments API. It was really designed for REST uses, and this use for search engines and embedding in HTML web pages was completely out of left field. We never designed it for that, and we were really surprised when the search engine companies said that it was okay to do that. So yeah, great question, Brad. Let's see, other questions. Nick. For knowing what can be done with the current resource, we've been using HTTP options. Is there anything similar in JSON-LD for giving hints about what can be done with a particular ID? I guess this could be done through a vocabulary. This is a great question, Nick, because I totally forgot to touch on this. That ID is special. Right? The ID is the ID for that node in what's called a graph. So the RDF data model is a graph-based data model. You have nodes that are linked to other nodes, right? And if you think about the web, that's exactly the type of data model that you want for the web, right? Because on the web, you have a web page that is linked to another web page. You have a website that links to other websites, right? It's a graph-based data model. And so RDF is a graph-based data model, and that ID, that at ID, identifies which node you're talking about, which web page you're talking about. So that's the old document-based way of thinking. The new thinking, remember, we're trying to change the web into this gigantic database of all human knowledge ever, and make it machine readable. So the biggest machine readable database of human knowledge that has ever existed. And the way that we express that information is through a graph-based model, right? And the things that link these nodes together are hyperlinks, right? So a hyperlink is what actually links one piece of information to another piece of information. So if you want to talk about something in linked data, you give it an ID and you give it a URL, such that when you do a get on that URL with a specific, it's called content negotiation. When you content negotiate for machine readable data, you will get a machine readable representation of that information back, or you should. That's the theory. So if you hit schema.org and you ask it for JSON-LD, you will get back a machine readable document. If, for example, in that case where I gave Jane an ID, so example.com/people/Jane, if I curl that URL, if I did a get, HTTP get on that URL, and I said I want JSON-LD data, I want machine readable data, instead of a web page, instead of a human readable web page, what I would get back is machine readable data. I would get a JSON-LD chunk back that explained what Jane's name was, that she was a person, what her phone number is, what her web page is, all that kind of stuff. And in a way that's machine readable, such that I then, that my machine can reason over it. And here's where it gets really interesting, right? So if I give Jane an ID, other websites can start talking about Jane, right? But in Jane's data, in Jane's JSON-LD data, Jane can also start talking about, that data document can talk about things like who Jane knows, right? And that's like, Facebook is calling it a social graph, right? But at the core of it, it's a graph, right? So Jane knows Bob. Jane knows hyperlink Larry. Jane knows hyperlink Mary, right? And so there are all these other nodes out there, and you should be able to do what's called following your nose. There's this concept, web architecture concept called follow your nose, where you start on one node, you start on Jane, and you follow your nose. Jane knows Mary, right? So Mary's her own node. Mary knows hyperlink Larry, right? Larry is employed by MIT, right? MIT is a university. MIT has a student named Nick, right? So that's how we traverse this gigantic graph of information. The graph is as big as the web is. It's got billions upon billions of nodes, hundreds of billions of links between all those nodes. And in order to reason, for a machine to reason, all it does is it does a graph traversal, right? Tell me the people that Jane knows that go to MIT, or show me all the acquaintances of Jane that know someone that goes to MIT. You'd start on the Jane node, you'd follow it to the next node, you'd follow that link to the next one until you got to MIT, and then you get to, Nick, right? So that's how this graph of information is traversed in a machine readable way to answer really complex questions. So hopefully that answered your question, Nick. The question that you asked is there anything similar in JSON-LD for giving hints about what can be done with a particular ID? An ID is a URL. It's a URL identifier, and everything on the machine readable web, when you do a get on that data and you say you want JSON-LD, what you will get back is a machine readable document. So any URL that's in a JSON-LD document, you should be able to go to and fetch a machine readable document from. And if you can't do that, if all you get back is HTML, then the machine knows there's nothing for me here. It's just a human readable document, and then you have to fall back to doing like natural language processing, NAI. And as we know, those don't work as well as we'd like them to. Let's see. Josh has asked, can you give us more technical details on some of the uses for JSON-LD, specifically for web payments? Okay, so I'm noting that the time's like 7:30, 7:40 Tulsa time, so everyone's been here for an hour. I really appreciate all of you sticking around, but I'm going to shut down the call soon after I answer these questions. So if you have any more questions, please put them in QA, because once I'm done with QA, I'm going to say thanks and bye and stop broadcasting. Okay, so Josh, can you give us more technical details on some of the uses for JSON-LD, specifically for web payments? So all payments go through this pretty standard process. It doesn't matter if you're using, like on the web, the process for sending money to someone is pretty standard, right? Let's say you're buying something, right? So step one is the payment request. The merchant says, I see that you want to buy this chair. The chair is $50. Please pay me, right? The second step is proving that you have paid to the merchant. So that's the Visa card network saying that you've been cleared for $50 in credit for the chair. It's the ACH network, Automated Check Clearinghouse network in the United States, that says that money has been direct debited from your bank account, or it's PayPal saying, yeah, this person has put money into your account through PayPal. So there's payment initiation, there's proof of purchase, and there's like the digital receipt that happens, right? Three things that are pretty standard. And in each one of those cases, you need some kind of data format to do the messaging. But the problem is that payments are an incredibly complex area. I mean, there's so so many details and intricacies of different payment networks operating in different countries and cross-border. I mean, it's dizzying how complex our payments infrastructure is. And because of that, we don't think we're going to get it right in the first pass. In fact, we think we're going to make a lot of mistakes in version 1 and version 2 and version 3. And what we need is an extensible messaging format that allows us to make those mistakes and recover from them, right? So we need to kind of inch towards the future as far as payments on the web. And the first thing that we're trying to do is just make it not matter if you're paying with a credit card or cash or Bitcoin or Ripple or ACH. We just, the payment instrument doesn't matter. And so the messaging format has to be able to express in bleeding detail exactly what's being requested, what's being sold. Like, it's a chair, it's a mahogany chair that's made out of X, Y, and Z, that was manufactured by so and so, that has a return policy of 90 days. You bought it from this vendor. These are the taxes that were associated with the sale. Like, all that information needs to be wrapped up into the payment request, so that when you see the message that you need to pay $50, you know exactly where all of that money is going, and you have a record of you paying, for example, taxes on that chair and all those other things. The technical details have to do with each market vertical, right? So a company that is selling a chair is going to put vastly different information in that digital receipt or the digital request for payment than, for example, say a chemical company that is selling hazardous chemicals, right? The chemical company is in a different market vertical. They're going to have a different set of vocabulary items that they want to put into the message. But the idea here is that the core message is JSON-LD, and each market vertical can slot their own terminology into the message. We don't need to go and standardize each one of these different market verticals. We just say the message is JSON-LD, and it can contain a bunch of different types of data from different types of market verticals. So hopefully, Josh, that kind of answers your question. Specifically for web payments, we need a very flexible data format that allows us to not build out the whole solution in version 1. It allows us to extend the solution as the years go on. So to give you an idea of the trajectory that we think we're on, there's a simple person-to-person payment, which is, I want to send Josh $10, right? And it's a fairly simple thing. It's just like, the message is like, the destination is Josh's bank account. Here's $10, done. Right? The next one is, I want to buy a product. So I want to send $10, $50 to this merchant for this chair that has these sets of attributes, right? So that's kind of the merchant use case. Or, I want the payment to go through the Visa payment clearing network, not the ACH payment clearing network, because I want the, Visa's faster. I'll get my thing faster if I don't send an electronic check. So you need to be able to mark up those types of messages. And then, when we go into the future, there are these things. So Bitcoin, I want to be able to pay in Bitcoin, and I want it to go through the Bitcoin payment clearing network, or I want it to go through Ripple or Ethereum. So that's kind of the near future. And the far future is, whenever I make a payment to Josh, here's a smart contract describing our relationship, a machine-readable contract that can be executed by software, such that when Josh or I do something very specific that can be measured, payment is moved from Josh's account to my account, or my account to Josh's account, based on what we do, right? So being able to express business relationships in code effectively is where we're headed with JSON-LD. And in order to do that, we can't solve that problem today. We know we're going to have to solve it in 5 to 10 years, but you need an extensible messaging format to do that, and you need a messaging format that a lot of developers are already fairly comfortable using. So that's why we're picking JSON and building JSON-LD on top of JSON. So hopefully, Josh, that answered your question. Are there any plans for JSON-LD beyond 1.0? If so, what are some of the issues with version 1 that would be addressed? So really great question, Nick. So when W3C creates a standard, if the standard is successful, that standard lives for about 10 to 15 years. Right? It's a huge, huge time frame. So there's a lot of pressure on the developers of these standards to get it right the first time, and to do the minimum necessary for success. So don't add any extraneous features. Don't add any nice-to-haves. Get the core there. Really understand what your extensibility story is, and then step away from the specification for a decade. Right? If you have to jump in and do a rev of the spec in 2 years, you didn't do it right. So there are many ideas for JSON-LD past 1.0. My personal opinion is that we shouldn't touch it for another 5 years. Everything that we've seen so far is showing that JSON-LD works for the things that it was designed to do. There are some things that we really would have liked to get in there, but as far as like catastrophic deficiencies or things that we really wish we would have gotten in there that we didn't get in there, we don't know of anything that is kind of a make or break thing. I mean, there are annoyances in there. Like for example, someone was talking the other day of, I have all this legacy JSON data, and I want to start generating IDs for them, but I don't want to change any of my JSON legacy data. Is there any way to generate URLs from a whole bunch of properties that exist in my JSON data today? And our answer to that, there are two answers. One of them is, yeah, we could add a JSON-LD feature that allows you to do that, a generator, URL generator feature. Or you could just run some JavaScript over that JSON data that you have. You could pre-process or post-process the JSON data. And typically that's our response to any, I really wish JSON-LD had X, is, well, you could probably write 10 lines of JavaScript to give you that feature. And we wouldn't need to complicate the standard with that, one feature that only maybe 2% of people using JSON-LD would need. So at present, there are no plans for JSON-LD 1.1 anytime soon. That's not to say that there are people that are pressuring for it, right? People love to see like a 1.1 version of the spec to get their special feature added in there, but there's no really strong driving need for a JSON-LD 1.1 yet. Keep in mind that JSON-LD was just ratified earlier this year. No, maybe it was last year. I think earlier last year. So people usually don't want to touch the spec until we have really good field data on how people are actually using it and what actually needs to change. And then we would only change it in a way that's backwards compatible. We never, ever want to do breaking changes for stuff that's out there on the web. So yeah, great question, Nick. Let's see. Google currently supports rich snippets via JSON-LD. This is David. Google currently supports rich snippets via JSON-LD markup for only events, site links, search boxes, and knowledge graph features, but not for products, recipes, reviews, etc. Is this because Google has a much weaker understanding of JSON-LD versus microdata? I don't think Google has a weak understanding of anything. I think so. Google started off with support for this stuff via microdata and RDFA. So I think the standard line from Google right now is that they support both microdata and RDFA for inline markup. Developers can use either and get their data into the Google search engine like that. JSON-LD is newer, so they're trying to see how web developers react to JSON-LD. So they've provided support, slow rollout of JSON-LD right now, but I think, again, this is, I do not speak for Google. I have no idea what their plans are, but I think what they're trying to do is a slow rollout. based on things that they've said at conferences. So I don't think it's a lack of understanding. They're trying to be very slow and calculated with the way they do this rollout. There's certainly a concern about hidden data and people abusing the feature if they roll it out too quickly. So they want to see if people are abusing it, and if they are, then they're probably not going to continue to roll out JSON-LD for the other mechanisms there. Again, this is not that's not my area of expertise. I'm not an SEO person or anything of that nature. So there are many other folks on Google Plus and Twitter that are SEO folks that are talking a lot about JSON-LD. So I try and do some searches for them and see what they have to say about that. Okay, last question from Brad. So using JSON-LD, if you have enough facts built up and contexts, would it be possible to then go backwards, having the machine create a page with the content that would be tuned to a user's preferences? Is there any planned standard for this idea? So yeah, great question. I forget the company that does this, but there's already a company that exists that actually writes entire newspaper articles. It's all machine generated, and it writes it in such a way that people just cannot tell the difference between a machine generating the article and a human. It's really, really good. They do a really fantastic job at it, and it's used for more like stuff like bad weather alerts or stock market reviews or traffic reports or things like that. But given enough facts, a machine should be able to write an article about anything it has enough facts for, right? I mean, that's all we're really doing up in here. We have a bunch of facts and we figure out how to organize them into a cohesive narrative. They already have, there's already software that understands how to create, take a bunch of facts and create a narrative out of them and write a web page based on that. As far as the standard for doing that, I think we're way too early. We're just now getting a handle on machine reasoning and things of that nature. So, for example, it was only really recently that IBM Watson, the IBM Watson supercomputer, was able to beat someone in Jeopardy, a human player in Jeopardy, and so all that stuff was using concepts that I've talked about today, right? Linked data, graph-based data structures, machine reasoning, RDF, all that kind of stuff was used to build Watson. And so I don't think that there's going to be a standard for doing that right now. That's really more of like an application. It's software that's written. There's no need for a data format or a protocol for doing that right now. So here's the thing that's important to understand about standards. Standards create larger marketplaces. They create larger ecosystems, right? And typically the things that you want to standardize to do that they're really two things. They're data formats and protocols. Typically, if you look at W3C or IETF, that's all they really work on is data formats and protocols to prove interoperability. HTTP, protocol, right? HTML, data format. JSON-LD, data format. JSON, data format, right? And so what you need is an extensible message format and a well-known protocol to get that message from point A to point B. And that's typically what we standardize. We don't standardize things like, how does a machine generate web pages from linked data? That's something that usually the market sorts out. So, for example, the IBM Watson supercomputer could be writing prescriptions, or it could be writing news articles, or anything that it has enough facts for. And that's really where these large companies, both small and large companies, come in and provide their value. So as far as I know, I don't think that there are any plans for standardizing that. But I mean, things can change in 5 years. Okay, so it's 9. Thank you everyone for sticking around as long as you have. I'm definitely going to shut down the call because I'm sure everyone's sick and tired of listening to me chat. Luke says, thanks. Luke says thanks for joining. Thanks again to Luke for inviting me to come and speak at the Tulsa meetup. Also, thanks to Brent Shumball, who really kind of pushed me to have this hangout and chat with folks here. So if we do this thing again, hopefully we'll be able to make it more interactive. That's one big bummer that I had about this was I was hoping to have more of a two-way conversation about JSON-LD. So we might do something in 2 weeks where I learn Google Plus Hangouts and how to actually interact with the folks that are listening. Okay, let me make one last pass through YouTube to make sure I'm not missing anything, and we will say goodbye. Okay, so I can't see anything on YouTube. Okay, everyone. Thanks for much. Thanks for, a bunch for joining. Hopefully, you found this helpful. I'm releasing 6 videos about JSON-LD and linked data and how JSON-LD is used in to do digital signatures on the web, to do credentials on the web, to do payments on the web. So if you just search for my name on YouTube, those videos should come up shortly. I'll be releasing the videos tomorrow at some point, and I'll try to give Luke a link to the document so that, or all of the links so that you can look at it on the Tulsa Web Devs list. Okay, thanks everyone a bunch, and if we have another hangout, I hope you join again, and I hope I get to talk to you. Thanks, bye.